School of Urban Studies and Planning. And along with my colleagues, Rob Bertini and Chris Monsieur, we help co-organize this weekly transportation seminar that I welcome all of you to. Some of you have not been here before, so welcome. In case you did not know, we do webcast seminars, which is one reason I'm standing here holding my finger on the microphone, which is something I'm going to ask you to do. If you do ask a question, please use the microphone, holding the touch button with the red light lit while you're asking the question so people who are watching on the web can hear your question. And we do have people watch both live on the web and then they're archived afterwards. So if you go to the website for the seminar, you can find, I think now, almost 3 years worth of seminars that are archived there that you can watch. So please remember to do that or I'll be nagging you. So without further ado, I'm going to introduce our speaker, who's Jay Lyman. He's a project manager for the consulting team of Dave and Evans Associates, who is working on the Columbia River Crossing project. And that is the topic for today.
Great. Thank you, Jennifer, and thank you for the chance to be here today. I have been looking forward to it, not the least of which is that, as you'll hear later in the presentation, that we have about 35 different agencies and firms working on the project, and many of those agencies and firms have PSU graduates in engineering and urban planning. And I know just by a rough count in our project office in Vancouver, there's at least 4 or 5 graduates in from PSU in engineering and urban planning. So the PSU has been a substantial contributor not only to our project, of course, but to the larger conversation about transportation and land use in Portland. I'm here to talk about the environmental impact study that we're currently undertaking for the I-5 Columbia River crossing. I'm going to talk a little bit about the history, how we got to having an environmental impact statement. I'm going to talk about the function and role of I-5 as it's currently performing, some of the transportation needs that have been identified that have led to the project moving forward. I'll talk a little bit about some of the design challenges that we're working to address. I'll touch briefly on project alternatives, and I say briefly because we're early in the process yet. And then last, I'll talk a little bit about process and schedule. Now, if I'm not normally a really strong speaker, so if you don't hear me in the back, please just tell me to speak up, okay? I'll put that as your job back there. A little bit about project history. The first bridge, there's 2 bridges side by side. The first one, which is currently used for northbound, was built in 1917 or opened in 1917. And when it opened, there was a 5-cent toll to cross the river. About in the early or the late 40s, with the post-war boom, people started talking about the need to provide more capacity across the river. And the western or southbound bridge was completed in 1958. The existing northbound bridge at that point was then reconstructed to raise the profile a little bit to match the new southbound bridge. And tolls went on in 1960, and they were taken off again in 1966. The tolls at that time were 20 cents for a vehicle and up to 60 cents for a truck. 3 lanes in each direction now. The next major crossing of the river was the Glen Jackson Bridge, was completed in 1982. You start to see a pattern that about every 30 years or so, there's been the need to push for another major investment in river crossing capacity. We're on that 30-year mark now. We're looking at trying to have the improvements to I-5 under construction by the year 2012, so it's almost exactly on that 30-year cycle. Current traffic volumes are roughly 135,000 vehicles on each bridge. By the time we get to 2020, which is our current forecast, the I-5 bridges are projected to be carrying about 180,000 vehicles per day. Over the years, there have been a number of studies. In fact, starting shortly after the Glen Jackson Bridge was completed, a number of studies have identified the need to do something to improve I-5. The most recent one and the most comprehensive was the I-5 Transportation and Trade Partnership Strategic Plan, which was completed in 2002. It had a number of recommendations, or wide-ranging recommendations, from demand management techniques that the region ought to be incorporating to a bunch of other things, but relative to the project, there was four specific recommendations. One was that we ought to be providing for high-capacity transit between Portland and Clark County. In particular, that study recommended that it should be light rail, and I'll come back to that in a bit. They also recommended 3 specific highway improvements to I-5. The first was to widen 99th Street to I-205 to 3 lanes in each direction. WashDOT has moved forward with that, and it'll be completed probably at the end of this year. The second project was to improve Delta Park, the Delta Park section of I-5, which, as you know, drops from 3 lanes to 2 southbound and northbound. Right now there are 3 lanes, but there are no shoulders in that section. That one, ODOT is just now completing the environmental assessment, and they anticipate the construction will start in 2008. The next and largest of the 3 projects that were specifically recommended by the strategic plan was to address the Columbia River crossing and the 2 miles north and south of the river crossing on I-5, a total of 8 interchanges. So in total, it's about 5 miles of improvements and 8 interchanges. Function and role. The I-5 is not up here, but I-5 is the only through interstate route between Canada and Mexico on the west coast. That's a critical function for freight movement. Obviously, it connects Washington and Oregon. In this 5-mile section that's shown here in the dashed line, there are, as I mentioned, a total of 8 interchanges. That includes connections with 4 state highways as well as 5 major arterial roadways. Provides access to a variety of land uses. You've got the city center for downtown Vancouver. You've got a regional shopping center on Hayden Island and residential activity there. Of course, your industrial properties in the Columbia Corridor for the Port of Portland, as well as other major shippers in that area. And the result of that is that you see some very interesting travel patterns. We did last fall a license plate video detection survey that captured all the vehicles entering and exiting on every entry and exit point in that 5-mile section of freeway. One of the things that came out was some pretty dramatic information about how people are using the bridge. Of the morning southbound trips in the AM peak, about 25% of those trips are entering the bridge influence area. I'll probably use BIA as an acronym, from north of SR 500 and proceeding through to south of Columbia Boulevard on I-5. So 1/4 are through trips as we define them for the project area. About 11% are trips that come in from the north and then get off in Oregon, but short of going through to Columbia Boulevard. About 40% are trips that enter primarily on SR 500 and SR 14 and head south. So that's your major commuter flow. And then finally, there's about 1/4 of all trips that actually get on within that 2-mile stretch north of the freeway and then get off before you get to Columbia Boulevard. So of the traffic that's crossing the river in the morning, only about 1/4 of it is actually extending through the whole length of the corridor. We have the similar pattern northbound. I won't go through all the numbers, but the result is very similar. You see that it's about 1/3 or 32% of the trips that are actually going all the way through, and nearly 40%, 38% are getting on and off. An important point to note is while a good substantial number of the trips are getting on and off in that short segment of freeway, that doesn't mean that they're short trips. From the modeling work that was done in 2002, the average trip distance for the trips crossing the river was about 16 miles. So what it means is that with only 2 bridges connecting the Vancouver and Portland metropolitan areas, there's a lot of people that are traveling substantial distances in order to cross the river. Let's talk about the need for the project, and it's broken into several categories. These are all taken directly from the formal purpose and need. Most of you, I'm sure, are aware that under the National Environmental Policy Act, one of the first things you have to identify is a formal purpose and need for the project. It was adopted early this year, and it had several categories. The first being that, no great surprise here, that travel demand exceeds capacity. And it exceeds it for a number of hours per day, which I'll show you some graphics in a little bit. Transit service has no alternative but to put up with the same congestion that all the other travel modes across the river do as well. We have impaired mobility for freight traffic, not only traveling through the area, but in access to the Port of Vancouver, Port of Portland, and other major freight centers. I'll talk a little bit more about crash rates. They're too high. They're significantly higher than averages. If you've ever tried to cross the bridge as a pedestrian or a bicyclist, you know that the facilities are poor and access to them are very inadequate. And finally, both Oregon and Washington have defined I-5 as a lifeline corridor, which means that they want it to essentially be operable soon after an earthquake or a major disaster takes place. These are old bridges. As I said, the newest one was built in 1958, and they were not designed to meet modern seismic standards. So part of our problem definition is identifying that and looking for alternatives to address it. So, pretty basic. Travel demand exceeds capacity. I'm not going to spend a lot of time there because I'm going to show you some graphics of that. Here's a plot of the northbound volumes, which would be the PM 2-hour volume. No, 1 hour volume. 2-hour volume, excuse me. No, 1 hour. It's this is over the from midnight to midnight. Northbound volumes. Okay, here we go. You can see that the demand in the blue line here gets up to about 6,000 vehicles per day in the afternoon. This gray bar that is illustrated here is approximately what we're finding by empirical evidence is the maximum that you can get across the bridge. A typical lane capacity would be more than 2,000 vehicles per hour per lane. But what we're finding, because of the configuration of the bridge with the ramps immediately north and south on both directions, that the actual capacity that you can get across the bridge is somewhere around 5,400 vehicles. So you can see that the demand that we calculated or observed from that license plate survey actually exceeds what you can physically get across the bridge. What does that mean? It means that there's a timed shift for some of the travel that's trying to use the bridge. Folks are entering it and they're getting caught in queues on the ramps, getting caught on the north end of the bridge or the south end of the bridge in this case, and they're having to wait in order to pass across the bridge. What that results in is right now, on average, we're seeing about a 4-hour congestion period every single day in the northbound. Quickly looking at the southbound one, you see the same pattern. Some diversion, but mostly at this point it's still just a matter of backing it up. We're about 2 hours on average in the morning when you see delays and backups that frequently occur for a mile or two or more south of the bridge or north of the bridge. Now, if you look at the forecast for 2020, we again show the blue line as the projected volumes, which get closer to 7,000 vehicles per day. With the same capacity on the system, you can see that what's going to happen is that there's a substantial curtailing of that peak because you simply can't get more traffic across the river. That means that you're going to see some shifting, some time shifting, both to earlier periods in the afternoon and later periods in the afternoon. And what that results in is approximately what we're estimating is somewhere around a 9 to 10 hour period of congestion every day, with the afternoon rush hour starting about 11 o'clock in the morning. Yes, sir.
Is the problem, you say, is it the bridges aren't wide? Is it the congestion before the bridges, or could, if it didn't have congestion before the bridges, would the 3 lanes of the bridge give you more capacity existing?
The northbound in particular, the question is it the bridge that's the problem, or is it the congestion somewhere else in the system? Right now, southbound, the single largest issue is the Delta Park section where it drops to 2 lanes. With the addition of the 3rd lane on that part of it, the bridge will become the most significant bottleneck. Northbound, it is the bridge, in fact, that's frequently causing queuing all the way back to I-405 and even down to I-84 and further south. And the same thing in the morning. If you look at the year 2020, our 2 hours is projected to go to 4.5 hours. So you're now up to 13 or 14 hours of congestion per day. And just a brief summary of that, if we don't do anything to the highway system and travel demands continue to increase as we're forecasting them, then our 6 hours plus per day now is going to go to 13 or 14 hours by the time we get to 2020. Let's talk a little bit about existing transit service. We have a combination of local bus service provided by TriMet, which has a route number 6, which goes over to the Vancouver Transit Center in downtown Vancouver, and then 5 commuter express routes serving Clark County and linking them to downtown Portland. Of course, just south of the river at the Expo Center, we have the northern terminus for the yellow line, Interstate Max. Getting across the river, as I mentioned earlier, right now there's no way to do that as a transit rider other than to put up with the same congestion that everyone else is dealing with. One of the results of that as you look to the future is, this again comes from the partnership study that I mentioned, which was completed in 2002, that the travel times from downtown Vancouver to downtown Portland, and this is PM peak hour, I believe, will go from about 27 minutes on average to over 55. There's a number of issues dealing with safety. We have looked at statistical analysis for the safety data for 2001 through 2004, compiled by both Washington DOT and the Oregon DOT. And I'll get into some of the statistics, but essentially we've been able to identify that the safety issues are significant, that they're caused by congestion, by the close proximity of the interchanges. I'll just stop there for a second, that the minimum federal standard for urban area interchanges is about 1 mile, and they prefer 2 miles between interchanges on an interstate system. With 8 interchanges in that 5-mile section, and if you take out the bridge from that, the average spacing between the interchanges is less than 1/2 mile apart. So the weaving issues and the short ramps, the accel lanes and decel lanes are a significant issue in the corridor, and you see that in the accident history. We come up by analysis, the 5-year period that we looked at in Oregon, at 1.34 collisions per million vehicle miles is twice the average for comparable urban freeways in Oregon, so that would be looking at the rest of I-5 south of the bridge influence area and I-84 and, of course, the Sunset Highway and 217. The collision rate in Washington is similar. It's about 1.23 collisions per million vehicle miles. Interestingly, Washington doesn't have that same sort of normative standard that we can compare and say whether it's higher or lower than their standard. One of the things we did for the project was look at exactly where the locations of the accidents were and the type of locations. These Pac-Man diagrams, I'm not sure what you want to call them, indicate the location and the number. So the larger the circle, the larger the number of accidents. The yellow are rear-enders. The red are side swipe. Blue is fixed object. And then green, I think, is other. So I won't go into a lot of detail on it, but what you can see is a couple of things to note. This is the Washington side of the river, that as you're coming southbound toward the bridge, the number of accidents southbound are much higher consistently than the number of northbound accidents. And second, that as you approach the bridge, you can see that the most severe accident histories are occurring right at the bridge head. If you look at the Oregon pattern, it's just the reverse. As you approach the bridge northbound, now you see a much higher frequency of accidents. And again, in general, the highest incident rate happens right at the bridgehead. And in fact, the single highest location for accidents in the area is on Hayden Island at the northbound on-ramp to I-5, where the where the on-ramp itself has about 150-foot taper. Federal standards for that are about 1,500 feet as a minimum. So it's about 1/10 of what you would think would be the normal standard. So this just summarizes a little bit about what I said. Most of the accidents are rear ends. You can see that by the scatter diagrams. The next most common type is side swipes, and that occurs for both Oregon and Washington. And the note that as you approach the bridge in both directions. The second thing, or another thing that we did was to try to correlate the location of the accidents with the substandard design features. And I was corrected. I shouldn't say substandard. I should say design features that no longer meet current standards, because they were designed, of course, to standard in 1917 or 1958 when they were built. So a number of different types of geometric issues that we looked at: the ramp-to-highway acceleration and highway-to-ramp deceleration, weaving areas, horizontal and vertical alignment, and shoulder widths. And just a graphic illustrating, again, the Washington side, the acceleration length where it does not meet, and deceleration where it doesn't meet standards, the weaving area issues where they do not meet standards, and horizontal alignment issues occurring mainly at the bridge, on the bridgehead on the Washington side. And finally, areas where we have substandard shoulders. And on the Washington side, it's almost exclusively related to the bridge structures. On the Oregon side, the same kind of information. The XL and decel issues show up here. Weaving areas occur in several locations. Horizontal alignments and vertical alignment issues. One of the more challenging one of the facts of life is that when they rebuilt the bridges in the late 50s and early 60s, in order to try to minimize the number of bridge lifts, they created a hump or a high spot in the bridges that are further south from the lift span to allow for most of the marine tug and barge operators to go through. In doing that, they decreased the speed profile for the hump and actually brought it down to a stopping sight distance of about 35 miles an hour on the bridge. So fortunately, most of the time the bridge is congested and people are traveling that speed. So just carrying this on, there are virtually no segments on the Oregon side where we have standard shoulders. Now the next thing you do is take a look at how that correlates with the accident history, and I won't dwell on that, but here's the picture of the Washington side again, and then you overlay that, and you see there's pretty much a one-to-one where you start to see the design deficiencies, and the same thing on the Oregon side. Another thing that we identified in looking at the accident histories was we did a correlation between the time of day of the accidents, both northbound and southbound, and the bridge lifts themselves. So we got the bridge tender logs and actually identified particular days and particular times that bridges were lifted, and then correlated that with the accident histories before and after. And what we found was a very striking correlation that there's about a 3 times higher likelihood of an accident northbound immediately following a bridge lift. What does that mean? It means that people are having to stop and are not paying attention, and they're rear-ending. And the same thing, but even more extreme on the southbound side, 4 times more likelihood of an accident after bridge lift on the Washington side. Why the difference? We think the difference is that there's actually an S curve approaching the bridge on the Washington side as you're heading southbound, so you don't have the same horizontal sight distances that you do northbound on the bridge. Finally, there's a strong correlation on the safety data between the time of day and accidents and congestion. Here's our travel volume plot, again, midnight to midnight, and northbound showing the frequency of crashes by hour sector. So you see that most of the pattern pretty generally follows, but then your frequency of accidents just about doubles relative to the change in traffic volume. So most of your accidents are happening in the congested period of the day. And if you do some statistical forecasting and look that out to 2020, you can see that you'd have a much larger period of the day with a much higher rate of accidents occurring if we don't do anything to fix the bridges. Next topic that we identified as a problem, the existing bridges have sidewalks on both outsides of the bridges. However, they range in width between 3 and 6 feet, and they're only separated from the travel lanes by just the Jersey barrier and another foot or two of clearance. So it's not a desirable or pleasant experience, and it's far substandard in terms of meeting width standards. That 3 to 6 compares with what we're looking at in terms of desirable for both ODOT and WashDOT standards of about 14 feet. Finally, I mentioned the seismic issues. We're currently doing a study to look at whether the bridges can even be upgraded to meet current seismic standards. It's far from certain that that's even a potential, which was going to have implications for the study because we have identified fixing that problem as a major part of what we're trying to address. Let's talk about some of the design challenges that we are facing here. This is a profile of the existing bridge with a little bit of vertical exaggeration to it. Washington on your right side, Oregon on the left. You can see the lift span near the north shore of the river. And right north of the bridge, just for information, there's a east-west transcontinental Burlington Northern line that crosses over the top of the freeway right as it lands on the Washington side of the river. One of the issues that we have to address is that immediately east of the I-5 corridor, they have a general aviation air park in Vancouver. It's Pearson Air Park. It's a historic facility. It's the only general aviation air park, I believe, that's operating in Clark County right now. We have been told in pretty uncertain terms that we can't think about relocating it and that we have to work around it. So what we have as a constraint is that we have to stay under the approach slope for the approaching and departing planes as they cross over the top of I-5. You'll notice that the existing towers are in that approach slope, and when we talked to FAA about can we grandfather this in, they said no, the towers actually existed before there was an FAA, so we don't get any points for that. The next challenge that we're trying to address is that right now there's the 2 lift spans. Each bridge has a lift span. It's on the North Shore, as I mentioned. We would love to find a way to build a bridge that doesn't have a lift span. In order to do that, you've got to be approximately in the range of about 100 feet, 110 feet off of the water. If you do that, you can see what happens. We are down to a very, very teeny window where we can actually try to snake a bridge through. And we're working with both the Coast Guard and Federal Aviation Administration to see if we can't get a little wiggle room in those green and yellow zones. But the good news is if it was only one federal agency and they didn't have the other constraint facing them, they probably wouldn't be very flexible. But what we're hearing from both the Coast Guard and the Federal Aviation Administration is they recognize how tight this is and they're trying to work with us. So then you overlay some profiles of potential bridge alignments on there. The lower one is about what we would do for a low-span movable bridge. It would still be higher than the existing bridges, would lift less often, but we would still require a movable span because, as you can see, we're not above the green zone for marine traffic. Note that on the north end, even the low alignment would take you over the top of the railroad. So now the touchdown point, or the way it's going to come down into Vancouver, is going to change significantly. The next line here in the middle is what we're calling our mid-height option. It's the one that we think has the most promise and the one that, frankly, we're spending the most time trying to find the right engineering solution for. It would not have a lift span, but it would just squeeze in that sweet spot between the river navigation clearance requirements and the height restrictions for airspace. Finally, this top line is one that we started off the conversation with the Federal Aviation Administration, or no, excuse me, the Coast Guard, because they said, well, we've got the Glenn Jackson Bridge upstream. It has about 144 feet off the water. Why don't you at least consider that? That way we know that we wouldn't be constraining the marine users any more than they're already constrained. They have since, based on a marine traffic survey, agreed with us that that would be extreme and that we don't need to go to that height because virtually none of the river users are using vessels that would require that kind of elevation. Plus, with the intrusion into the airspace for Pearson Air Park, we have essentially removed this high alignment from consideration. Another challenge for us is that the highway bridges here, this is again the Vancouver shore and Hayden Island on the other side, are separated by only about a mile from the Burlington Northern Bridge, which is downstream. It also has its opening on the North Shore. And as I mentioned, when the bridges were rebuilt in the late 50s and early 60s and the hump was created, that was intended so that most of the commercial traffic could use that center span. What it forces them to do, though, is to make a kind of an S-curve as they go through this. And in times of high water or rapid flow, the tug operators will choose not to try to use that or even can't use it if the water is high enough, and instead will wait for an opportunity to pass through the lift span. And the reason I said wait is that by agreement with the Coast Guard, traditionally bridges have to respond to a call for clearance 24 hours a day. But because this is an interstate, the Coast Guard has agreed to allow a non-opening periods of between 6:30 and 9 in the morning and 2:30 and 6 at night. So there are several hours a day where vessels cannot call for a lift during the weekday. But so if you're carrying a cargo down, you'll have to tie up and wait if the water is high or fast moving. Just this in schematic, one of the challenges that it creates for us, there's the straight through shot. There's your S-curve. If you start thinking about building a bridge to supplement the existing bridges, in other words, we want to keep the existing bridge or bridges in place. We want to build something next to it to also have it function to carry traffic or transit across the river. You're either going to do that upstream or downstream. The Coast Guard has said they're unhappy with the number of hazards to navigation that already exist in the river based on the river piers, and that they're going to look very carefully at our pier placement if we try to do this. So one of the challenges that we're looking at is, can we actually put the piers in a way upstream or downstream that will allow the most cumbersome vessels out there are the tug and barge operators, allow them to be able to navigate through without further impeding their S-curve. And we're not certain that we're going to be able to do that. That could be a fatal flaw more for this one, the downstream supplemental bridge, than the upstream one, because you can set your piers on the upstream side to line up so that where people can pass through pretty much on the S-curve they are now, but the more you tighten the distance between the last obstacle here and here, the more you make it difficult for the tug operators to get through. Yes, sir?
Several years ago, there was a talk of rebuilding the new railroad bridge, rebuilding it, doing something. Is that a possibility? Can that, well, it certainly can be rebuilt. If you rebuilt it, would you put the channel somewhere else in that railroad bridge?
The railroad bridge, just a little bit of background, about 4 years ago, an application was made for Truman Hobbs funding, which is a federal program for reconstruction of bridges that have a safety problem. It wasn't approved by the Coast Guard. It would have done exactly what was just suggested there, is move the lift span for the railroad bridge to further out into the middle. That would have diminished the S-curve required and would have improved the safety for the tug and barge operators. The way we're dealing with that is we're starting to look at alternatives, and if we find something that's attractive in terms of one of these combinations, but only would work if you have to move the span, then we would include the movement of that span as part of that project description, and it would be factored into the cost and environmental impacts of that. So I wanted to touch briefly on some of the other design issues. Of course, we talked about addressing the Coast Guard and the marine and the aviation issues. We're recognizing that we're talking about a major reconstruction of a freeway in an urban area. Immediately east of the freeway in Vancouver is the Fort Vancouver Historic Site. For those of you familiar with the EIS process, those are all 4F properties, and they're going to be, essentially we've told, we're working under the supposition that we can't touch them. There's another park here, businesses and historic buildings on the west side of Vancouver, businesses and residences and neighborhoods on Hayden Island. We're working closely with the floating home associations here in particular, who are concerned about impacts to their community. And of course you've got wetlands and the Delta Park recreational area here. So it's a very constrained project area, and while we're using the term threading the needle to find that sweet spot vertically, and essentially we're threading the needle horizontally as well. Jim?
That brings me to a question that I had earlier when you were talking about the crash statistics and trying to fix those half-mile distance between interchanges. I mean, those interchanges are still going to be there primarily. I mean, how are you going to design approaches on both sides that still maintain access to those roads?
That's a good question. In general, we are assuming that the interchanges are going to be there, although there are a couple of places where we're interested in talking with the City of Vancouver and the City of Portland about whether changes in access would be consistent with what their transportation plans are. But the details of addressing a bad weaving section, the technical solutions, I'm going to start waving my arms here, but essentially you start figuring out how you can get people on and get people off without having them cross. So you separate them vertically. You braid the ramps, or you start combining ramps so that the Terwilliger interchange here, just south of here, is a good example of a collector-distributor type system where an on-ramp blends with an off-ramp before they split. So there are different design techniques that you can use to try to avoid conflict areas on the freeway, or if nothing else, at least have them occur in a slower speed section of the roadway. Project alternatives. Just last Wednesday, 2 days ago, we have a task force, which I'll talk a little bit about in a second, but they agreed to narrow the range of ideas or components, as we call them, for consideration. Our next work over the next several months is putting more detail into what would be considered full project alternatives. About the best I can say is that all of them will include aggressive transportation demand management and transportation system management measures. We will be looking at replacement bridges, that you'd build something new and then take down the existing bridges, or supplemental bridges where you'd build something new and find a use for the existing bridges. We will be looking at several different bus alternatives, ranging from express buses in general purpose lanes on the freeway up to a full BRT, bus rapid transit system, and LRT. One of the things that came out of the task force meeting Wednesday night was the task force asked us to do a bit more work on commuter rail. So depending on how they respond to further information next time, we may actually be taking a commuter rail option further as well. If you start thinking about a bridge crossing the river, one of the things you have to consider is how do you use those lanes? Given the travel patterns that I showed you earlier, one of the things that's of interest to the City of Portland and the City of Vancouver is, can we get some benefit out of having an arterial connection that would essentially connect Maine or Columbia in downtown Vancouver across to Hayden Island and then across to Marine Drive and onto the city grid system in Portland. So we will be looking at arterial lanes, and then of course we'll be looking at freeway lanes in both the general purpose mode as well as managed lanes such as HOV or hot lanes. I've mentioned the 8 interchanges. This is where we'll get into how do we address those from a design perspective while minimizing impacts to all of the adjacent development and resources that we're trying to protect. We are going to be looking at some specific freight improvements. Just an example of that that we've been asked to look at is to use managed lanes, again HOV hot lanes, as a potential for a truck-only lane during periods of the day. So we'll be considering that and measuring whether or not that's a viable solution, given that it's probably only going to be able to be implemented in this 5-mile section that we're looking at. And finally, anything we do is going to incorporate substantial improvements to bicycle and pedestrian connections across the river. And not just the connections themselves, but also trying to improve access to those connections. If you've ever tried to bicycle across there, as I mentioned, it's a bit of a challenge. Here are a few graphics of, I've mentioned supplemental replacement bridges. This is a graphic of a downstream bridge, so it would be west of the existing, it would replace it, and it would be mid-span. Now, we haven't gotten to the point where we're considering structure types, but this is an example of a type that would be similar to Glen Jackson, where it would be a concrete box girder bridge. This shows a low-level upstream bridge replacement. So we would take out the existing bridges and put in a low-level movable. Because of the tower issue, it's likely that if we do go to a movable system, we would not be able to use a conventional lift like you see there now. It would probably have to be a bascule bridge or maybe a swing span. This shows the idea now where you would consider building something adjacent to the existing bridges and then keeping the existing bridges in service. So this is a supplemental bridge downstream, and again it's mid-level, or low-level, I'm sorry, we just don't have the lift shown. And finally a replacement bridge downstream. So a variety, and this one actually shows the column sticking up in the area. Is pretty hard to see in the graphic, but it's a variation of a cable-stayed bridge called variously extrados or extrados. I've heard it both ways, where it's a combination of deck construction and cable support, so that you end up getting a little bit of the best of both worlds. The advantage to that would be that your towers and your cables are lower than they would be under a more traditional cable-stayed bridge. Briefly, process and schedule. This is a little bit of a Noah's Ark of agencies. It seems like everywhere we touch one, we have to have two. Because this is a transit and a highway project, we have two federal leads. We have FTA and FHWA. We have the two DOTs. In terms of regional partners, we have the two DOTs who are the lead local agencies, but we also have two cities, two transit districts, and two MPOs that are actively participating as partners in the project. And to a lesser extent, we also have two counties and two port districts that are actively involved. So just in those top two groups, there's 14 federal, state, and local agencies that are working on the project. We have done something as a first in the country. Actually, there's several firsts in the country. This is, while the project is one of about 20 or 25 projects that FHWA is tracking that are over $1 billion. It's one of about 20 or 25 in that category. It's a much smaller number when you think about those that are bi-state. And when you get down to a bi-state multimodal one, we believe it's the only one in the country that meets all that criteria that we're working on right now. Along with that, we have created the first in the nation streamlining agreement for the environmental review and permitting. It's involving all the state and federal agencies that typically would have to sign off on an EIS or issue a permit. So we have U.S. Fish and Wildlife, the Corps of Engineers, the state agencies on both sides of the river, EPA. They have adopted as their name of their group Interstate Collaborative Environmental Process. And it is being used as a model around the country now for how to streamline the involvement of those agencies. Our task force is our citizens group that's looking over the project. There are 39 members of that. They're meeting monthly. They represent neighborhoods, interest groups such as the tug and barge operators, truck operators, shippers, AAA. We have the cities and the transit districts represented. We tried to cast the net pretty wide. It's a very cumbersome group to work with, but there's an awful lot of people who have a stake in the process. We also have a number of working groups that are working at various levels. We have a freight working group, an environmental justice working group, a transit working group, and they're all involving multiple jurisdictions as well as the consulting team. And finally, our project development team. We have a project office in Vancouver with about 60 people stationed there now. It's a mix of DOT staff from both Oregon and Washington DOTs. We have several of our local partners that have assigned staff to the office. And then we have about 25 consulting firms all working as one team on this project. At any one point, we typically have several hundred people working on the project every month. So it's a massive undertaking. We're right now our goal is to get the record of decision by the end of 2008. We're working on a very aggressive schedule, and that's why there's such an intense staffing effort on it. Some things I haven't talked about that I just wanted to end up with. We have a big challenge ahead of us. We don't know what the cost is. The partnership study estimated that the project would cost somewhere around $1.5 billion or so. We don't know how that's going to be paid for. We are working on that. One of the options we are going to be considering is tolling. The FHWA has a mega projects fund specifically set aside for large projects, and of course FTA has New Starts money, which we are trying to line up for. And this region has been very successful over the years, of course, in getting New Starts money for that. Project delivery options, what I mean by that is it's going to go the traditional design and then put it out for contractor and then build it, or we're going to look for more innovative ways, a design build, or even a public-private partnership where a private entity might put up money to finance the bridge and build it and then operate it. That's on the table for consideration. Ownership, we have to address who's going to own both the bridges and whatever kind of high-capacity transit system is ultimately carried forward. The bridges right now, the existing bridges, are jointly owned by WashDOT and ODOT. They're maintained by ODOT. There are several varieties of ownership that we could be considering. Most likely, it's going to still be one of those two agencies, but it could be something else as well. And then high-capacity transit right now, the operator and owner of our transit system, or of our light rail system, is TriMet. If they go across the river, that's not part of their service district, so that's going to have to be worked out. And if it's a bus rapid transit system, would that be CTran? Would it be TriMet? All of these things are on the table. And finally, operations. Whoever owns it may be the operator, or it may be somebody different. So it's just because there's so many partners involved that some of the things that you would take for granted in terms of who's going to own and operate it are out there as open questions. And that's where I get to the questions. Yes, sir.
I was wondering why the yellow line light rail wasn't originally extended across the bridge.
Well, there's a good number of folks in the room with a lot of history on the project, but I can take a stab at it. The region did a proposal, they called it the South-North EIS, that would have extended light rail into Clark County. It required a vote for funding in both the Oregon side and the Washington side. It failed when it went to a vote in Clark County. So the short version of the story is because Clark County chose not to come up with the funding at that point, that Oregon essentially went forward on their own and found an innovative way to get it at least as far as Expo. Yes, sir.
Has a tunnel been taken off the table?
At Wednesday's meeting, the task force took a long tunnel as a replacement bridge off the table. And what that would have meant was a tunnel that would have been bored and come up. It's kind of hard to show without a map, but it would have been several mile long tunnel that would have essentially missed several of the interchanges. You couldn't serve Hayden Island. You couldn't serve SR 14, which is immediately on the north end of the bridge. That one went away because there was no effective way to make the connections. And if you remember back to what I said about the travel patterns, so much of the traffic across the bridge is coming in and on and off the interchanges that are immediately north and south. We still have on the table what we're calling a supplemental tunnel, which would keep the existing bridges in place, but would create a shorter distance tunnel that would try to capture access to as many of the interchanges as possible. Frankly, we're finding a lot of problems with that as well, that in order to get it to be shorter distance, you've got to have it shallower, closer to the surface. The only way you can do that is you would have to physically dredge out a channel across the river and then plunk down your tunnel structure. The folks that are in charge of protecting fish in the river have already told us that's not a very desirable option. Plus, when you get to the north side of the river, when you're into creating that kind of a tunnel, which is essentially cutting and then covering it back up again, you're going to have pretty significant impacts, and even construction-related feasibility is a question for trying to cross through either downtown Vancouver or the Fort Vancouver side. So the supplemental tunnel is not dead, but it's on life support, and we promised to come back to the task force next time with a technical report recommending it either go forward or not.
Follow up on that, to using your license plate survey and recognizing that it looked like roughly a quarter of the traffic was going beyond the BIA, have you been able to determine how much traffic in fact would be removed by a longer tunnel that is not dependent on those interchanges that are immediately adjacent to the river?
Well, a different way of slicing that same question would be to say that if you build the long tunnel, you would still have so much traffic on the surface that you'd have to replace the existing bridges anyway, because you wouldn't be able to, you'd still have the same congestion issues that we're dealing with now. For example, we're forecasting traffic to increase by 25-30% between now and 2020. If you took that 25% off and had it in a long-distance tunnel, you'd still have the same congestion that we've got today, plus you'd still have the same old bridges in terms of the seismic issues and the same safety problems. So we're looking at that as not a very effective solution. Yes, sir?
Can that downstream crossing alleviate enough traffic on the present I-5 to maybe salvage the I-5 and do seismic upgrades? I mean, I know there's a group that has a proposal for that. It's basically the railroad corridor there.
Right.
So.
We did, when we did our NEPA scoping process, we heard from folks that wanted us to look at a wide range of corridors, all the way from Camas to Troutdale connection, all the way to an I-605, which would have been across Forest, the West Hills and down into Washington County. One of the ideas that came, well, actually a couple of them, were to use the railroad corridor 1 mile west of I-5 and build a new transportation corridor for vehicles as well. We actually modeled that with the Metro model and found that you're still going to have most of your traffic on I-5. I think there was a 15% reduction in the year 2020. Plus, you're still going to have all the issues that I just mentioned about the tunnel. If you haven't touched the existing bridges, so you'd still have the safety and seismic issues. So yes, you could go back in and address the seismic things, but you wouldn't have taken enough traffic off to effectively manage the problems that we're seeing now. Rob?
We have some questions from our web viewers, and the first one is regarding commuter rail. Are there plans to incorporate a high-speed rail link, or I guess would the rail connection allow for high-speed rail in the future?
We, to this point, our work on commuter rail has been relying on two prior studies, one by the Regional Transportation Council on the Washington side, and that was completed in the late 1990s, and the second was conducted as part of the I-5 Partnership Study in 2001 and 2002. Both of those studies looked at the development of a commuter rail system on the existing tracks, as well as the potential of, or the potential need to actually construct new tracks adjacent to the existing tracks. What they found was that given the amount of freight traffic on the existing railroad system, coupling that with the intercity Amtrak service, there was virtually no capacity left to provide for commuter rail on the existing tracks. You could build a second set or a second and third set of tracks immediately adjacent to the existing tracks, but that would get into billions of dollars, and the ridership that was forecast for that was less than what we saw for either a really aggressive bus system to linking Clark County to downtown or a good light rail system. We took from that it wasn't an appropriate solution to try to incorporate in this project, but the recommendation from the partnership was that if and when you are starting to think about improvements to the rail system, make those improvements robust enough to address a high-speed rail link from Portland north, make them robust enough to address potential use for commuter rail. Our task force on Wednesday was faced with a question about whether to take commuter rail off the table or not, and they left it on the table for more information. We may end up, as a result of their action, doing more work on that, but at this point we don't quite know where we're going to go with it. Are there other questions, Rob?
There was a question about when the overall project we could expect to be completed. You have the ROD in 2008, and then the same web viewer asked whether the thought is that Clark County citizens would be more supportive of rail if they needed to come forward with funding at this stage.
First question, when would it be completed? The best we can anticipate for start of construction would be probably 2010, perhaps on a really aggressive schedule under one of these innovative delivery things that I talked about, a public-private partnership, for example. Conceivably, you could see some action starting to happen in 2009, but more likely it would be 2010, the earliest to start. And then given the scale of the project, if it's done all in a sequence, we think it's probably a 3 or 4, maybe even a 5-year sequence to complete it. The second question was about the support within Clark County. We haven't done any formal polling yet, but we have done open houses, and we have a survey that we conducted as part of our own website. What we're finding is the attitudes in the mid-'90s when the South-North vote was taken were not favorable to light rail for a number of reasons, but we seem to be finding a lot more interest in a balanced transportation system, including some form of high-capacity transit. Is very strong interest in that, and even within that group, there seems to be a fair number of people that are more willing to consider light rail at this time around. We are going to be doing some more detailed polling later on this year, and we hope to get a better handle on what public perceptions are. But at this point, we're optimistic that what we're hearing from non-statistically valid sources seems to be there is more interest at least. Yes, sir, and then in the back.
Seems that light rail will be supported greater as capacity diminishes. So, I mean, for Clark County, if the congestion gets bad, they're going to support light rail more. But question on the Pearson Airfield issue: if you move the graphic that you had that showed the very narrow area, if you're looking at moving a bridge span east, does that narrow your area considerably, and why is FAA so intent on preserving this tiny little, slightly anachronistic airfield?
Two questions there. The first, the altitude or the height that you have to stay underneath does vary directly, because the farther away, it's a projection on a 1 to 40 slope or something like that as you get away from the end of the runway. So the farther away from the runway, the more maneuvering room you have. It is more of a challenge for us to build an upstream bridge, or one east of the existing bridges, from that perspective than it is to build one on the downstream side. We don't think it's out of the range of feasibility. We have looked at a replacement bridge at a mid-height level upstream, and we think we can get it in that window that we showed. Interestingly, when you talk about a supplemental bridge, one of the twists that you get into is that your highest point on that supplemental bridge has to match up with the existing lift spans, because that's where your maximum height for your navigation channel would be. It forces your maximum height on your bridge to the North Shore, and therefore you really are into the airspace on that one. So the task force took off the table Wednesday the idea of a supplemental upstream mid-height bridge, but we have a replacement mid-height bridge upstream. And I can get into more detail if you like. The second part was, why does FAA care? I don't think they're the ones that are driving the decision whether to keep it open or not, but the city of Vancouver is very much anxious, and is Clark County anxious to keep it alive, because it is the only general aviation facility. Also, it is a historic property, and their long-term plans actually call for having it being used primarily as a facility for historic airplanes, which have to fly under general visual flight rules, which means that those are actually more restrictive than the instrument flight rules. So it's an interesting challenge. You had your hand up next.
Yes. I'm wondering if there's been any consideration that the older of the two bridges that are existing there, if that older bridge could become your means of creating greater pedestrian and bicycle access by making that kind of bicycle and pedestrian only.
We have several ideas that we're starting to flesh out where you would build a new bridge adjacent to the existing bridges, and reuse the existing bridges for some other function. Those other functions are going to come down to either local traffic, transit, or some improvements to bicycle and pedestrians. So yes, we are looking at using those existing bridges in some form for improving the bike and ped connections across the river. I think, sir, you were next, and then Jim after you.
Building on that thought, have you, and also looking as I'm recalling now, your origin and destination, your time of day data, and your directional data, it would seem like a supplemental bridge with access somewhere in Delta Park, Columbia Boulevard on the south end, and access to SR 500 at the north end, a supplemental bridge that was reversible lane would handle the demand and not get tied up in the close-in access constraints that the existing bridges have. And then the existing bridges would also facilitate tolling, partial tolling, and a number of things. Have you considered reversible lanes, I guess, is my major question.
Yes, we have, and one of the things that, well, I guess I'll give you the punchline. We have concluded that reversible lanes are probably not an effective strategy for this corridor, largely because we're seeing a convergence in the directional splits for AM and PM, and expect with the continued growth in Clark County, with it rising at a faster rate than the Portland side of the river, that will eventually be much like what you see now with a Seattle-Bellevue split, where it's virtually identical AM and PM both directions. So we see the freeway going that way fairly strongly, and the splits that we're forecasting 20 years out are much less than they are right now. So we're probably not going to be looking at reversible systems. Rob?
More web viewer questions. I'll start with these first two. Was the traffic analysis such that you could look at whether increased capacity across the bridge would induce more growth in Clark County? And also, perhaps one issue that hasn't really come up yet is the question of whether the I-5 increased capacity would draw traffic from the I-205 crossing.
Two very good questions. The first one, we're going to have to do a lot more work on as part of the environmental impact study, but there was preliminary work done during the partnership. Metro used their Metroscope model to consider changes in land use as a result in changes of capacity to I-5. One of the conclusions they came to from that was that I-5 was actually supportive of the planned land uses on both sides of the river. Improvements to I-5 would be supportive because it would allow continued use and development of the existing and planned employment centers that depend on I-5. If you don't make those improvements, actually the opposite occurs. You start to see more spread out employment. And that report went into a lot more detail than that, but that was one of the principal conclusions, that from an employment and land use management perspective, it was the providing capacity in the I-5 corridor was actually beneficial. Tell me the second. 205, thank you. We will again be doing more work on it, but what we found in the partnership study was there was a fairly significant demand shift to I-5 when you added capacity to it. What that tells us is that there's a lot of people using 205 now that are doing it because of the congestion on I-5. The shorter, faster, more efficient trip for them would be using the I-5 corridor, but because there's a lack of capacity, they're actually going over to I-205. We'll be testing that further, and actually testing it under a couple of interesting variations. We have to, as I mentioned, tolling is going to be one of the options that we have to look at. We're going to be testing what happens to that diversion between I-5 and I-205 with and without tolling applied to the I-5 corridor. So that's going to be another way to look at the issue. Yes, ma'am. Jennifer?
Actually, I have a question. We had a student who had to leave early, and he left me a question for you. And last year, we had a real estate planning workshop class that looked at some of these issues in downtown Vancouver. And one of the concerns that came up in that was whether a bridge, whether the northbound landing would sort of bypass downtown Vancouver and have potentially negative economic development impacts on downtown Vancouver. And has that come up, and maybe how some of the options might address that problem?
I did show in that very simple schematic the general profile for what a mid-height bridge would look at. Our best analysis so far is that the touchdown point would be, where it would come back to existing grade, would be somewhere around 6th Street in Vancouver, which is pretty close to the river. We wouldn't lose any of the connections that are there now. You'd still be able to connect to SR 14. You'd still be able to have a city center exit northbound. City of Vancouver staff are actually fairly excited by it, because what it would do is elevate the bridge, elevate I-5 for the first quarter mile or so north of the river, and that it would allow for better east-west connectivity along their riverfront. So by being up a little bit, you'd be able to have pedestrian and bicycle and auto connections back and forth, east and west. A lot more work has to be done on that, but so far it's looking reasonably promising. Jim, you had your hand up a while ago.
I was going to ask a question about the seismic stuff. What triggers an upgrade? In other words, if you build a supplemental bridge and leave the other ones alone, do you still have to upgrade, seismic upgrade the existing bridges? It's almost sounding to me like leaving those bridges up in any way is going to be really problematic.
The trigger will be in part the function of the bridges once you have the supplemental bridge in place. I'll give you an example. If you build a supplemental bridge and freeway traffic goes on that supplemental bridge, and you use one of the existing bridges, say for light rail, it's going to be a decision that the light rail owner and operator and FTA will make whether they will allow that bridge to be converted to light rail use without seismic upgrade. Now, this is all aside from the question about whether it's even feasible, because we don't know that yet. I guess that's the best answer. It's if we turn it over, if we build a new bridge, freeway goes on it, it becomes an arterial. There's 4 potential owners that immediately come to mind. It's either City of Vancouver, City of Portland, Multnomah County, or Clark County. Would any of those jurisdictions be willing to accept it without having that seismic upgrade as part of it? So it's an open question. Yes, sir.
Yeah, and in your surveys, what has been the response to your ideal of congestion tolling?
We haven't hit the question of tolling or congestion tolling head on in the one introductory survey that we did. However, we've had a couple of focus groups. We're going to have more focus groups. And the 2 focus groups were one from the Portland side, one from the Vancouver side. It was very interesting to us watching through the mirror as these focus groups were taking place. The level of sophisticated understanding about tolling, about electronic tolling, and about congestion pricing from just people picked at random off of a phone selection. People were generally aware of tolling. Most of them had heard of electronic tolling technologies like transponders. And a lot of them were very interested in congestion pricing, because they say it's fair. If you want to use it at the peak time, you pay more than you would in off-peak times. Those are not statistically valid samples. There were 2 groups of 12 or 13 people. But at first blush, we found that pretty interesting. It also tied in pretty well with a study that Washington State DOT just recently completed, looking statewide at moving toward a statewide tolling authority or something similar, and essentially saying that most of the new capacity would be provided or paid for by some kind of a tolling program. They did a statewide focus group effort, including outreach to folks in the Vancouver area. And again, one of the conclusions was that there's a pretty strong sense from that people are willing to see tolling go in if it's for something that they're going to use and they will get benefit from. That one, I don't recall whether it answered specifically a congestion pricing question or not. Yes, sir.
That last response is pretty much private autos, and I haven't heard anything specific about trucks. So you got truck-only lanes, if you got pricing for trucks that gets away from weight mile taxes or something, do you distinguish in any way the role of trucks in this growth?
Trucks account for roughly 8 to 10% of the daily traffic on I-5. It seems like more than that because, of course, they're large and they take up more space, but they're about 10%. There's a long ways to go before we make any decisions about if tolling is applied, how it would be applied, or what the tolling rates would be. For certainly trucks would be expected to pay proportionally more than cars. We don't really have a policy yet on how much more they would, and that's something that's going to come out over time. Would it replace the weight mile tax? Probably not, because it would be, we'd make the argument that it's tied specifically to paying off the bridge, unless you go to a congestion management in which it's a policy that you're paying just for the capacity that's provided during different times of day.
Well, I asked the question for a couple of reasons. One, you're talking about where employment centers are, and there's distribution centers and other things laid on an area. So you've talked about east-west traffic under the bridge on the Vancouver side. I'm interested whether there's any discussion of the St. John's Bridge, not for passenger commuters, but for access to developing or enhanced job places or distribution centers. And it doesn't sound like that freight element's been integrated very well yet into your figuring capacities.
We're certainly looking at moving traffic that's projected to go on I-5 and approaching I-5 from all of the major feeders from the ports and the shippers. For example, Marine Drive is probably the highest volume truck corridor approaching I-5. Mill Plain serving the Port of Vancouver. That's all part of the picture. We're not at this point looking at a corridor or affecting a St. John's Bridge picture, except to the extent that we would be recognizing that those trucks that are making any kind of connection through there that get to I-5 would have to be accommodated on I-5. I'm not sure if I got to your question, sir. We did remove from consideration options that would have created a new corridor along the railroad to St. John's.
I understand that. I was either asking a longer range question, or I know you cut off this project 6 miles or something like that. This is really a longer question about, as the region continues to grow, are you going to enhance some other employment and distribution centers significantly off of I-5 so that those trips don't need to even go on I-5? And again, I'm not talking about commuter trips. I'm talking about how freight gets distributed and whatever.
I'm not sure how to answer that. The identified development areas for shipping, for freight-related activities, we're trying to respond to those within the bounds of our 5-mile project. So, in the back, sir.
Just wondering, how many acres of land, will be either condemned, and what type of uses are there already, and then whether that'll change, from current zoning to something different.
We don't know yet what the impacts. Most of our discussion so far has been talking fairly conceptually about how to cross the river and what kind of transit connections or what kind of transit modes. Over the next 6 months or 8 months, we will be taking those general concepts and developing them from a design perspective and reporting back to our task force and the other groups that I mentioned, what those impacts, what the benefits of those would be and what the impacts would be. Right now, we don't have any sense at all of what the extent of impacts would be. You can pretty well look at the land uses immediately adjacent to I-5 through Vancouver and Hayden Island and in North Portland and identify the things that are of concern. North of Mill Plain in Vancouver, you've got residential properties abutting both sides of the freeway. South of Mill Plain, you've got, I'm very generically speaking now, you've got the historic properties on the east side, and you've got commercial and some historic on the west side. Hayden Island, immediately adjacent to it, it's likely any impacts would be largely commercial because of the strip, the commercial properties immediately adjacent. But there are floating home communities that are almost virtually underneath the existing bridge at the Oregon Slough right now. So all of those things are areas of concern, but I can't tell you what the impacts from any one alternative would be at this point. Rob?
One of our smart students asked maybe a good question to close with, and how did you get this job? And maybe more broadly, what was the process by which you formed the team and that David Evans and Associates was identified as the team leader? But I think hearing how you got where you are would be interesting too.
You want to tackle that one first, or I guess, boy. I've been with DEA for 16 years. Before that, I was with another firm for 10 years, and before that, another firm. So I've been doing this a long time. And I guess I'm going to keep doing it till I get it right. I was lucky enough to be a part of the first ODOT, WashDOT study conducted in recent years, which was the I-5 Trade Corridor study. And I played a fairly significant role in that. And it turned out that when that study was completed and when they started thinking about the partnership study, I was kind of the logical one to become the consultant team project manager for the team that we proposed then. And we were successful, and I was the consulting team project manager for that part of the work. When this phase, the EIS phase, came, DEA felt like that our history on the project would be, something that would help set us aside from the competitors. And we'd had a long relationship with Parsons Brinkerhoff and some others on the prior two phases, so we wanted to continue that relationship. And then in identifying the scale of the project, which is huge by this region's standards, and the complexity of the project, we started adding other major players. And I'll just name a few. Parametrics is leading our environmental studies. They have a great reputation for doing that kind of work. CH2M is a significant partner. Enviro Issues, which is a communications firm, is a significant partner. I won't go into there's 20-some on the list. We got the project. The Oregon and Washington DOTs agreed to move forward with soliciting consulting help for doing the environmental impact statement. And in February or March last year, they issued a request for qualifications. We had been working for months to have our team ready for that submittal because we knew it were coming, and we put a submittal in that was deemed to be successful. Partly it was deemed to be successful because it was the only one that was put in. But thank you all very much. I guess we're out of time here.
We are, and I will make the plug for next week. We have two of our graduate students from our Urban and Regional Planning program, Aaron Wilson and Sumi Malik, who are going to be talking about some of the research that they're doing, one about walking distances to transit, and the other about commute mode choice at large employment sites in the Portland region. So I hope to see some of you there. Thank you very much.
Thank you.